Hello and welcome back to Networking for Beginners. So, we have already covered the topics until here. So, in this session, I'm going to cover the rest of the topics, which are enterprise network, wide area network, what is DHCP, the DORA process, what are the DNS services. So, let's head over to the slide which is talking about the enterprise network. So by definition, what is enterprise network? From our previous slide, we have already talked about small office, home office, uh, which was basically having just few devices like routers, um, Apple iPod, computers, laptops, printers. But when it comes to enterprise network, it means we are talking about the large infrastructure. So by definition, an enterprise network helps employees and machines to communicate, share files, access file system, and analyze the performance of an IT environment that drives business operation. So the goal is almost same that we were achieving in a small network where I was demonstrating only two computers, which are connected with what? The physical cable, which could be the Ethernet cable. So the goal was to share the files from this system to another system and vice versa. So the same goal or the same objective we want to achieve in our enterprise network as well. Sharing files, access the system, analyze the performance, and these kind of stuff. Okay, so the goals are same. So this is how uh, the enterprise network look like. So and what are the devices that could make enterprise network a enterprise network? Could be the end host, and we are familiar what are the end hosts. The end hosts are these users, those basically using um, computers to access the file systems or any kind of uh, application that is being running in your infrastructure. Then we have switches, and we are familiar with the switches. These how the switches represent. Okay, so the basic idea of the switch we have already discussed. It is switching. Basically, what does it mean switching? Switching means just forwarding the data. Whatever this user wants to communicate with this user, okay, it will go via what? Switch. Okay, so it is basically switching the packets or just forwarding the packet. That's it. And another goal of having switches is you can, like, as you can see, you are connecting this network with another network, or you are extending the capability of a network. Okay, you are just expanding a network. So this is where you need a switches. Then we have a routers. We also talked about the router in our previous slides, that the basic idea of router is to connect to multiple networks. As you can see, currently we have how many networks here? um, we have this one network. Okay, then we have this second network, then we have this third network, and then we have this fourth network. Different network means they are using different IP scheme. Okay, the IP addresses that are being used on the part of here on this switch here, somewhere here, is different than this one, then this one, and then this one. Okay, so they are connecting different networks so they can communicate. So that is the main basic reason of using routers in your enterprise network. Then we have MLS or multi-layer switches. Okay, so if you basically combine switch with the router, we get multi-layer switches. So this is very advanced. Usually we cover this in the CCNA and CCNP level, but since we are just scratching the surfaces of these technologies, just to make you aware what multi-layer switches is. Okay, so we are having the benefit of switches with the routers. So multi-layer switch have both capabilities. But if we talk about the switches, switches don't have the capability of routing. And routers does not have a fast switching capability, which we can enable in a multi-layer switches in simple. Then we have wireless access point, wireless LAN controllers, as you can see here, because these end hosts are connected via wire that is directly connected to the switch. But the possibility could be in your enterprise environment, we could have the users without having wires. So what is the remedy? What is the solution? This is where we are gonna use wireless access point and wireless LAN controllers. Okay, so without having wire, these users can access the information that resides in the data centers through the wireless LAN controllers. Then we have firewalls, IPS and IDS. So these are basically intrusion prevention system and intrusion detection systems. These were a kind of old devices that were being used in back in old days, like uh, you know um, basically some kind of sensors are installed on these firewalls that will detect some anomalies, okay, or any kind of you know paranormal activities on the network. But now we have next gen, which is also known as next generation firewalls. So they are much more advanced as compared to these firewalls, but these firewalls are still in use, and it is good to know about them. Okay, so where these firewalls exist, usually as you can see, I have talked about the cloud computing. Cloud area means we have this cloud. In simple words, this is internet, and we know the internet is not safe. Whatever this user wants to communicate with the user that exists here, okay, maybe she want to share some file with this person, and if they are not using any kind of encryption, it will go through what, this naked internet. And maybe some person or some disgruntled person sitting in some internet service provider, and he is just sniffing those information, and if he have if he get hands on those files, he just can manipulate or get all the information that she want to share with the other person. Okay, so this is internet cloud. For that we require a security, and usually this happens with the help of VPN, virtual private network. That is a little bit advanced, but it is always good to have the knowledge about these terminologies. So let's head over to the next slide, which is talking about WAN or wide area network. So we have already talked about small office, home office. We have talked about the enterprise network. But what if one enterprise network wants to communicate with another network, with another enterprise network, which is far, far, far away from the first enterprise network? For example, let's take example here. This is the enterprise network. Let's say uh, this is job skill share organization in United States. Then we have another one, job skill share in Pakistan. So what in case this user wants to communicate with this user in Pakistan? How are they gonna communicate? They are gonna communicate with the help of wide area network through this cloud. And what is this cloud? So a wide area network is a telecommunications network that extend over a large geographic area for the primary purpose of computer network. Wide area networks are often established with the least telecommunication circuits. It means, as you can see here, we have this enterprise network here that we have already talked about, and they want to communicate with this some kind of a network over here in Pakistan. But how are they going to communicate? Of course, they should have some kind of intermediary device or intermediary some kind of the connectivity. And what is that? This is basically service providers, ISPs. So they are providing these leased line kind of circuits on both end. Okay, so this could be the service provider. This could be the service provider that is sitting in United States, and here the service provider that is sitting in maybe in somewhere in Pakistan. Okay, so this enterprise network will connect with US service provider with the help of what? Usually the routers. The routers that sits in the service provider are known as provider edge, PE routers. And the router, this is also provider edge router. And the router that exists in our enterprise network, let's suppose this one will be the customer edge router, CE. This one is CE, customer edge router. Okay, so they will run some kind of configuration in these routers, so that will be like the mirrored copy of each other, with some exceptions, so they both routers can communicate with each other. Okay, so this is how usually one network can communicate with another network, and this is how they can share the information with each other using this service provider. So basically, if I zoom this thing, what is it? It is nothing but the service provider with its own infrastructure. Infrastructure could be LAN. Okay, means they are using switches, they are using router inside that. So one service provider is connected with another service provider, another service provider is connected with the third service provider, and this is so on and on and on until they reach the service provider in Asia or Pakistan. And by the way, this is very advanced topic, but just for sake of information, I am sharing how two service providers, like service provider in United States is connected with the service provider, let's suppose in Pakistan. How are they both connected with each other? Of course, they also have these routers in between, and they have somehow connectivity in between. But what kind of protocol they are running? That is BGP, Border Gateway Protocol. That is very advanced topic, but just for sake of information, these two routers are sharing all kind of information having this BGP peering or BGP routers, BGP protocol, sorry. Okay, so this is how in a fraction of uh, second, your all information reach to another part. That is why they are geographical area. Means geographically they are located in a far location from each other. So that is known as wide area network. So let's head over to the next slide. So let's talk about the DHCP. By definition, the dynamic host configuration protocol is a network management protocol used on internet protocol network for automatically assign IP addresses and other communication parameters to device connected to the network using a client server architecture. So, you know, just imagine you have one switch that is connected with multiple computers. Okay, and let's suppose these are all connected with this switch. Okay, and then you as a server administrator, you have to configure IP addresses for these all devices. So what are you gonna do? You will go one by one on each device, and then you will provide IP address manually. And we have already talked about the IP address in our last slides, that what is IP. Okay, just keep it in mind, it's just the identification of that device. Okay, and every computer should have different identity. If two computer has same identity, they will not be able to communicate. Okay, so you as network admin will go one by one on every device, and then will configure IP address, subnet mask, or all the relevant information on that computer. So these are just bunch of computers. Let's suppose you have more than 500 computers exist in your organization. Are you really going to configure IP addresses one by one on every device? Never ever. If you want, just best of luck then, because I am giving you here some benefits and the disadvantages of using manual IP here as well. So it is a overhead and a burden for network administrator, and he or she can mistakenly put the wrong IP as well. Then you will have to troubleshoot all day long to find out what is the problem. So to mitigate this solution, to mitigate this issue, what you will do? You will just purchase one DHCP server, and you will give the responsibility to this server, which will be the DHCP server, to assign IP addresses automatically in a single go to these all devices that exist in your infrastructure. So you can imagine how much less burden is on your as a network administrator. So this is the basic benefit of having the DHCP server. Okay. So by definition, I have already given you the definition. So let's talk about the benefits of using DHCP. Here we have manual IP configuration. Let me change the color. Here is the manual IP configuration, and here is the automatic IP. So let's talk about the manual IP configuration. IP addresses are entered manually. So you will have to go one by one and to assign the IP on every machine that exists in your network. Then we have we have IP address could be entered incorrectly. Means the possibility and the chances are, because everybody make a mistake, the chances are you are going to put the same IP address or maybe extremely different IP range on two computers. Okay, so it will end up making these two computers in trouble. They will not be able to communicate with each other. So this is also a pain for the network administrator. Communication and network issue can result, of course, when you are putting wrong IP addresses, there is a communication issue. Then frequent computer moves increase administrative effort. So of course, this is not obvious. This is obvious that uh, if you have a laptop, okay, you will move, you will roam around everywhere. Okay, you will not just keep sitting in one desk. When you will go another desk, you will move to another department, then you will have to change the IP as well. So this is a overhead and a burden for network administrator using manual IP configuration. Okay, so on other hand, we have automatic IP configuration. IP addresses are supplied automatically. Correct configuration information is ensured, 100% ensured, because um, computer is like a robot. You have configured everything on top of that, and it is not going to make any mistake later on. Client configuration update automatically. Of course, if one client roam to another department or move to another department, automatically the IP address will be assigned accordingly. Okay, so there is no any kind of error margin. Then a common source of network problem is eliminated. Of course, if the DHCP server is taking care of it, you are not going to face any kind of issues. And at this point of time, everybody will be familiar how and from where they are going to see these IPv4 properties or settings. If I can show you from start, go to run and type ncpa.cpl. Okay, ncpa.cpl and hit enter. It will take you to the network connection. Another method to reach this area, you can right click here in this small, you can see a small connection here, internet access. Right click, open network and internet settings. From here, go into the Ethernet and change adapter options. You will go to the same location that you were doing before using ncpa.cpl command. From here, you can see local area connection. So this is basically this network interface card. This is network interface card is connected with what? My wireless router. Okay, which is handing over the IP addresses. So this my router is also working as what? The DHCP server. Okay. So to check the IP, what you can do? Right click, go to the properties, and then here we have IPv4 settings. Select this one, go to the properties, and here you can see currently my router is handing over this IP address automatically to me. Okay, if I want to add manually, as I was telling you earlier, for example, if you want to hard code your IP address, what you can do, select this checkbox or radio button, use the following IP address, and then put IP address manually here. Okay, so this is the method uh, to configure IP address either automatically or So let's get back to our slide. Okay, so this I have shown you the diagram or the picture here, which is I just demonstrated. So let's head over to the next slide, which is talking about the DORA process. So you know, uh, we assume that we have a one server, we have one machine that is handing over IP to us. But can you imagine how this happens behind the scene, this whole process? How our client machine know about the DHCP server and vice versa. So that is the process that run behind the scene is known as DORA process. So this is basically the abbreviation which stand for what? Discover, offer, request, and acknowledgement. So this is a four-step process that help us getting an IP address automatically. So by definition, DORA is a process that is used by DHCP or DHCP server. DORA helps in providing an IP address to the host or client machine. DORA is the process that follows some steps between the server and client. It gets the IP address from the centralized server. So what are those processes? So this is what happens behind the scene. If I will illustrate server here, we have one server. Since the server is on right side, I will put server on right side, and we have one client device on left. So first thing happens, what? The DHCP server will not do anything. Who is willing to get IP? Of course, the client machine. So client machine will initiate the first packet or the first process or the first step in the process, which is what? Discover. DHCP discover. As you can see, the source IP means what is the IP exist on this PC. As you can see, currently it does not have any kind of IP because this is what we are heading. We are searching for IP address from the DHCP server. So what will happen? This client machine will initiate DHCP discover process or step. So it is saying, this machine is saying my IP is currently nothing, 0.0.0.0. Okay, my IP, which is source, is null. But I want to get to this destination, which is what? 255.255.255.255. I have already mentioned here. Means if there is any DHCP server reside on my local area network on my network, I want to approach that machine. Okay, so although the DHCP server has some kind of IP address which is 10.0.0.100, but this machine is totally blind because it doesn't know about the DHCP server yet. But it knows with help of what? Means of course it want to communicate with help of what? And in last slides I have already talked about every application runs a kind of protocol for identification, which is what? UDP boot PC 67. So 67 basically is the protocol which runs on top of UDP, which says that I want to reach to the server. If it's 67, it means I'm heading toward the server. Okay, I'm looking for server who has this port number 67 for the DHCP. On other hand, so at this point of time, now this request will be initiated and it will reach to the DHCP server. DHCP server will get this request and will look into the packet. Okay, so in next step what will happen? So in the next step, now the source is what? Source is the IP of this DHCP server, because now our next step is DHCP offer. So this first request has been already submitted to the server. Server looked into the packet and it just find out that somebody's looking for IP address. So I am going to uh, send him a offer. So currently the source is the IP of my DHCP server, and the protocol, my protocol number is 67. I am heading toward where? Protocol number 68, which is what? The DHCP client. So these are the identification number. 67 is for server and 68 is for client. That is why when the client initiated, it initiated from its own 68, heading toward where? 67. And this, because the server is now responding, so my protocol number is 67, I am heading toward 68. Okay, so the source is 10.0.0.100, which is the IP of this DHCP server, because the DHCP server will always be configured manually with the IP. Okay, only the client machine that is not having a IP address. So the server will then reply back with offer, and offer will have some kind of information like IP address, subnet mask, default gateway. Okay, so these kind of package will be sent back to the client machine. So once the client machine will receive that packet, it will look into it and it will say, yeah, that is fine, that is this IP is what I'm looking for. So it will send a request back to the server. Kindly assign me this IP. Okay, so as you still can see, the source is still not familiar for this client. It is sending blindly to this DHCP server with the broadcast. This is called the broadcast. All 255, 255, 255. Going from client machine to the server. So the server will receive this request and it will acknowledge back to the client machine, yes, here you go. This is the package that you are looking for. I have handed over to you and I acknowledge it that you have received. Okay, so this is the 4-step process that happens in a DHCP assignment, IP address assignment. So if I will show you the animation for that, so this is how DHCP discover will be sent to the server. Server will send back the DHCP offer to the client. Then client will initiate DHCP request back to the server saying that I'm interested for this package. Then server will acknowledge that here you go, this is your IP address that you are looking for. Okay, so let's over to the next slide. So let's talk about the DNS.